The Hubble telescope has been our space buddy for years, taking incredible photos and collecting facts about the stars and planets. It lets us peek far into the universe to discover its amazing secrets. Hubble was awesome, but scientists imagined an even cooler telescope. They wanted one so strong it could spot the very first stars and galaxies, letting us peek at what the universe looked like when it was just starting out, almost like traveling back. From this ambitious vision, they imagined and began designing the James Webb Space Telescope, or JWST, as it would come to be known. Building the JWST was like solving a giant space puzzle. First, it took 20 years because scientists wanted it to be perfect, and it cost $10 billion. The reality of building this new telescope presented a challenge, pushing the limits of engineering and scientific innovation. JWST needed to be absolutely huge, with a primary mirror far larger than any previous space telescope, in order to catch the incredibly faint and ancient light from the early universe. Furthermore, it needed to be colder than anything else in space, operating at incredibly low temperatures to effectively detect infrared light, which is key to seeing those distant objects. The sheer size of the main mirror presented another hurdle. It had to be bigger than any rocket could possibly carry in its fully assembled form. And to keep the telescope's delicate parts safe from the sun's strong heat, the sun shield must block it with unmatched efficiency. It needed to perform as effectively as a tennis court-sized umbrella, providing a constant shadow for the telescope's delicate components. Every single part of this complex machine had to function perfectly, without fail. Because once launched, there would be no possibility of repairs in the vast emptiness of space. No one can just fix it 1 million miles from Earth. To overcome these challenges, thousands of brilliant scientists and highly skilled engineers from all around the world joined forces for a unique global project. Through teamwork and never giving up, they slowly turned a wild and impossible dream into something real and exciting. The ultimate goal was clear: to build a new and more powerful eye on the universe that is ready and capable to reveal some of the deepest and most profound cosmic secrets that have eluded us for so long. What started as sketches and models became shiny metal parts and golden mirrors. The telescope was no longer just an idea, it was becoming real. And so, the incredible journey to design, build, and ultimately launch the James Webb Space Telescope had officially begun. The heart of JWST is its giant golden mirror over 6 times bigger than Hubble's. To fit inside a rocket, the team designed it in 18 hexagonal segments folding up like origami. Each segment is made of lightweight beryllium and coated with a whisper-thin layer of gold perfect for reflecting infrared light. The hexagons fit together seamlessly, creating one massive, precise surface. Tiny motors on each segment allow for perfect alignment in space. Years of testing ensured the mirror would unfold and focus flawlessly. This engineering marvel would let JWST see the faintest, oldest light in the universe. To keep JWST operating at its peak performance, it needs to be incredibly cold. We're talking temperatures far below freezing, colder than anything you'd find on Earth. To achieve these really cold temperatures, engineers designed and created a remarkable 5-layer sun shield. This isn't just any ordinary shield, it's a feat of engineering. When fully deployed, the sun shield is the size of a tennis court, providing a massive barrier against the sun's intense heat. It's made from an ultra-thin, incredibly strong material called Captain, specially designed to withstand the harsh conditions of space. Like origami, the ancient art of paper folding, the sun shield is carefully folded into a compact package for launch, allowing it to fit inside the rocket. Once in space, it carefully opens up, step by step, acting as a big space umbrella to block the infrared radiation and heat from the sun, as well as the heat radiating from Earth and the Moon. Each of the 5 layers is designed to radiate heat away into space, acting like a series of thermal blankets. This allows the telescope side to stay incredibly cold, colder than any freezer you could find on Earth, creating the perfect conditions for infrared observation. The deployment of the sun shield relies on hundreds of cables, pulleys, and pins, all of which had to work in perfect sequence with absolute precision. A single snag or malfunction could have spelled the end of the entire mission. To minimize the risk, the engineers practiced and tested the unfolding process on Earth many times to make sure it would work in space. The sunshield's hot side, facing the sun, can reach temperatures hot enough to boil water, while the cold side, shielded from the sun's rays, lets JWists see the faintest cosmic signals from the most distant stars and galaxies. This remarkable sunshield is truly JWist's secret weapon, its key to unlocking the universe's mysteries. The design was risky, pushing the limits of engineering, but it was absolutely essential for the telescope's ambitious mission to unravel the secrets of the cosmos. And now, with the sunshield successfully deployed, JWST could finally peer into the universe's hidden past, revealing the secrets of the early universe and the formation of galaxies. After decades of careful planning, countless hours of engineering, and dedication of scientists and engineers from around the globe, JWST finally launched on Christmas Day, 2021, a gift to humanity promising to unlock the deepest mysteries of the cosmos. It's carefully folded and loaded onto a powerful Ariane 5 rocket. People all over the world watched closely. Families gathered and scientists waited nervously. The rocket soared into space, carrying with it the hopes and dreams of a generation of astronomers. It was a moment of hope, a leap into the unknown, but also a moment filled with nerves, knowing the challenges that lay ahead. The real test, the truly nail-biting part, began immediately after launch. JWST had to unfold itself, slowly and carefully, like a space ballet where every move had to be just right, and all of this had to happen 1,000,000 miles from Earth, far beyond our reach. Over 300 parts had to work perfectly, like a well-tuned machine. There was absolutely no room for error. A single misstep could jeopardize the entire mission. First, the solar panels deployed, giving JWST the power it needed. Then, the massive sunshield unfurled, layer by delicate layer, protecting the telescope from the sun's heat. Finally, the 18 hexagonal mirrors clicked perfectly into place, forming the giant eye that would gaze into the cosmos. Mission control erupted in cheers with each successful step, a wave of relief washing over the team. The sense of relief grew exponentially with every milestone achieved, a testament to the team's hard work and dedication. JWist continued its journey to a special spot in space called L2, a gravitational sweet spot. This location made sure the sunshield always blocked the sun, keeping JWST's delicate instruments safe. There, far from the heat and light of Earth and the sun, it slowly cooled down and got ready to open its golden eye to the universe. It was a bold and complicated mission, and somehow it had worked. JWST was finally fully deployed and ready to explore the cosmos, a beacon of hope and discovery. The universe's deepest secrets were now within reach, waiting to be unveiled by this magnificent telescope. With JWST in place, the first images stunned the world, thousands of galaxies, some never seen before. Its infrared vision revealed newborn stars hidden inside cosmic clouds and detailed views of planets like Jupiter and Neptune. JWST studies exoplanets, searching for water and signs of life by analyzing their atmospheres. Every picture is a new discovery, a leap in our understanding of the cosmos. The telescope's journey is a triumph of curiosity, teamwork, and persistence. JWST reminds us to keep asking big questions and exploring the unknown. Its adventure is just beginning with many more secrets to uncover. Who knows what wonders it will reveal next?